everyone. So I hope the audio and video is clear. So welcome to this topic. Welcome to this interview question where we are going to discuss this topic called calendar matching, right? And in this video, this is basically the part one, as you can see in the heading. So in this video, I'm going to be discussing the approach first, and then in the second video, the part one, I'll be writing the code, right? And discussing the kind of revising the approach side by side as well, right? So calendar matching, right? What will be given from the interviewer's aspect or the interviewer's side is basically the schedule or the time schedule of two persons, right? So basically, for fun, I just written the names here. So you can see this is the first person, Alex, and this is the second person, Sasha, right? Or Sasha, whatever you may call it. Now, these are the time schedules given for both of them in the form of an array, okay? And definitely we will take care of whatever the representation is. So for example, in the question, it might be in the decimal format or in the string format, okay? So we have to find out, right? We have to find out. So looking at both of those time schedules, right? So looking at the time schedule of person one and looking at the time schedule of person two, you have to find out the meeting, you have to find out or schedule a meeting between those two people, and the meeting duration should be of at least 30 minutes. And again, up here I have written what? 30 minutes, right? Up here you can see the meeting duration is 30 minutes. But in your case, it might be n minutes. So whatever the minutes it is, you have to be writing that approach, right? For example, it's going to be the same approach, just the variable will be changed, right? So for example, it might be 50 minutes, 1 hour, 2 hours, 3 hours, 5 hours, or even 5 or 15 or 10 minutes, right? So you have to schedule between the person one and person two a meeting of at least 30 minutes. So what if the person one, for example, what if Alex and Sasha are available for only 29 minutes? No, you cannot schedule a meeting between them, right? If they are available for 30 minutes or greater than 30 minutes. So it can be 1 hour, 45 minutes, whatever the case may be. So that's it. And you have to schedule the meeting between them. So for example, I'll just dry run, or maybe I just go over one of those arrays. So we have Alex here. So it said that Alex is busy from 9 a.m. till 10:30 a.m. Okay. Then Alex is busy from 12 p.m. till 13 p.m. Or you can kind of figure this 13 as 1 p.m. right? It's represented in the 24-hour format kind of a thing, right? So Alex is busy or not available from 9 a.m. till 10:30 a.m. and then from 12 p.m. till 1 p.m. Okay. Then we have this Alex is not available from 4 p.m. till 6 p.m. Okay. And this is the overall kind of scheduled meeting for Alex. Okay. And then notice one important thing which is given here. Alex's start and end time for the entire day. So Alex kind of starts his day at 9 a.m. and ends his day at 8 p.m. Okay. What that means is that we can see here that he starts his day at 9 a.m. right? So he kind of attends this meeting at 9 a.m. But we can see here that he ends his meeting at 6 p.m. right? At the end of the day, he ends his meeting at 6 p.m. Okay. I'll just erase that. So he ends his meeting, the end of the day, his meeting ends at 6 p.m. But the availability for Alex for the entire day is said that the start and the end time, right? So the end time is till 8 p.m. So I can kind of say that Alex is available partially apart from his job. He is available from 18 till 20, right? Which means he's available from 6 p.m. to 8 p.m. So you can kind of figure this out, right? So I'll just quickly erase this. So that's something you have to kind of observe in this problem, okay? Now this was all about Alex. So the same thing goes for Sasha. You can see here, these many are the availabilities, right? So this is the availability array, or maybe the scheduled time meetings for Sasha, right? And then we have Sasha's start and end time, right? So that kind of makes sense here, okay? So this is the output we are expecting, or the interviewer is expecting from your end. And we can, as a naive approach, or as a human being, we can kind of look at those two schedules and easily say, right, that okay, Alex is available from this time till this time, and Sasha is also available from, suppose, time S1 till end S1 or S2, right? And then we can schedule the meeting. But how do we code that, right? How do we tell our computer or tell the machine to code that, right? So that's the main part. So you can kind of see here, if you pause the video and kind of match these outputs with the availabilities, you will see that it's valid, right? And again, it said that meeting duration is at least 30 minutes. So up here you can see that from 11:30 to 12, that's 30 minutes, right? From 15 to 16, that's 1 hour. So again, that's 1 hour is 60 minutes. So 60 minutes is greater than 30 minutes. And it kind of satisfies the criteria of at least 30 minutes. Then again, we have from 18 to 18:30, which means from 6 p.m. till 6:30 p.m., right? Again, that's at least 30 minutes or equal to 30 minutes as in this case. So up here you can see that, for example, if I take any output like 15 to 6, right? So this is like 3 p.m. till 4 p.m. So, okay, we'll just check. Is Alex available from 15 till 4 p.m. or is Alex available from 3 p.m. till 4 p.m.? Let's check. Okay. Yeah, we can see that Alex is available. See, we have no meeting from 15, right? So up here, if there was any meeting, it should appear up here, right? But there's no meeting up there. And he's starting a meeting at 4 p.m., but that's another case, right? So he is available from 3 p.m. till 4 p.m. Let's talk about Sasha. Yeah. So again, Sasha is having a meeting ending at 3 p.m. and again, that's something you can ignore as of now. So basically, Sasha is also available from 15 till 4 p.m. or which it kind of means that she is available from 3 p.m. till 4 p.m. right? So you can kind of go through each one of these outputs which I've written here, right? And then kind of map them with their availabilities. So how do we do that, right? Well, we are going to be merging these. Hi, sorry for the little interruption, but let's begin. So I was talking about the merging part, right? So basically we are going to merge both of their availabilities or both of their scheduled meetings, right? And then kind of figure out where there is a gap or availability in both the cases, right? So for example, if Alex is available from 10 to 11 and Sasha is available from 10 to 11, then surely we can schedule a meeting. But what if Alex is available from 10 to 11 and Sasha is not available, or vice versa? Then in that case, we are bounded by restrictions, right? So basically, before even doing that, I'm going to make both of these arrays or both of these input arrays on equal terms. What do I mean by that is basically I'm going to be appending some values to the start or to the beginning on the end of the arrays in both the cases, and kind of making the initial values in both the arrays and the last values in both the arrays same, right? So this is a simple kind of an approach here. What I'm going to do is simply look at the start time here, which is actually 9 a.m. and then kind of write 00, or maybe I can just write 00 till 9, right? And this is going to be appended to the start of the array named Alex, right? And at the end, I'll just write a comma here. So that's 20 till 23 and 59, right? So I think that kind of makes sense because this is basically the free time, right? So from 12 o'clock midnight till 9 a.m. Alex is free. And then from 8 p.m. till 23:59. And why I'm writing 23:59 not 00? Because 23:59 is basically the last moment of the day, right? Or the last second of the day. That's what I want here. So 20 till 23:59. As simple as that, right? Again, up here, I'll be just appending to the Sasha array. So basically, I'll just write 00 and I'll just pick the start time here, which is 10, right? And at the end, I'll be just appending this value 1830, right? So 1830 till 23:59, right? So that's how the appending values should take place, okay? So what I'll do is I'll just quickly kind of try to modify this up here, or maybe I'll just leave it as it is, right? I was just thinking of writing it inside the array, but okay, this kind of is clearer to you, okay? So now we are on equal terms. For example, if I take a look at Alex and Sasha's array, we are starting at 0 and we are ending at 23:59. How good is that, right? So let's kind of merge this. And how do we merge this, right? So to merge this array, right, we are going to be using the concept of merge sort here, right? So merge sort is kind of a sorting algorithm which takes n log n time complexity, but in this case, I believe so it will be big O of C1 plus C2 or big O of T1 plus T2. Why T1 plus T2? Basically, my T1 is going to be, or maybe like not T1 but N1, right? So N1 is the length of Alex's array and N2 is the length of Sasha's array. So basically, merging these two arrays into one single array will take n1 plus n2 time complexity, right? So big O of n1 plus n2. And I hope that makes sense. So how do we do that? Well, I'll just try to write this array up here, right? And then you can kind of easily figure out what I'm doing, okay? So I'll just make an array like merged, right? So merged, okay? And I'll just write it in yellow itself, so it's clear as of now. So I'll be having 2 pointers, right? I'll be having 2 pointers on both Sasha and Alex's array. So I'll just highlight it here. So I'm having 1 pointer at Alex and 1 pointer at Sasha. And why have I taken the pointers at the beginning? Because hey, that's what we do, right? We take the pointers at the beginning and go until or traverse until the end of the array or respective length of the array, okay? I hope everything is clear as of now or up till now. So what I'm going to be doing is comparing the beginning time of the information available, right? So the beginning time of the beginning time of all of those indexes is basically up here. The beginning time is 0, 0. I mean 0, and then up here it's 0 as well. So which is less, right? So I'll be just comparing them. So for example, if the beginning time at Alex is less than the beginning time at Sasha, then I'll insert Alex's time in the merged part and then the Sasha's part, right? And then so on, whatever the case is, right? So in this case, I'm seeing that both of them are equal. So I can kind of take any one of them, okay? I can kind of take any one of them. So in this case, I'll be just writing 0, 0 till 9, right? And as of now, my pointer from Alex moves to 9 till 10:30. But my pointer at Sasha is still at 0 and 10, okay? And again, I'm going to compare or consider the beginning time of Sasha's, so that's 0, and the beginning time of Alex, so that's 9. So which is less? I know for a fact that Sasha's beginning time is less. So again, I'll just insert 0 till 10 here. So I'll just write 0 till 10, right? And again, my pointer at Sasha's array will be moved to 10 and 11:30, okay? And then again, I'll just start to compare. So 9 and 10, which is less? 9, right? So I'll just insert the 9 one. So that's 9 till 10:30. Again, my pointer will be increased here, right? I'm just kind of highlighting it so that we know where we are at, right? And then again, we are going to compare 12 and 10. So which is less? 10, right? So I'll just take 10 here till 11:30, right? And again, my pointer at Sasha is going to be increased, okay? Again, I'll just compare 12 and 12:30. So I'll just pick 12 because 12 is less. I think I won't be able to accommodate everything up here. So I'll just write it in another line. So 12 till 13, right? My pointer goes one place forward, as simple as that. And then again, I compare 12:30 till and 16, right? So which is less? 12:30, right? So I'll just write 12:30 till 14:30. 14:30. I think the screen is kind of lagging a bit, but that's okay. Again, I'll be moving my pointer at Sasha's array till 14:30 and 15. Okay, let's compare again. 16 and 14:30, which is less, right? 14:30 is less, right? So I'll just write 14:30 till 15, right? And then again, I will move the pointer in Sasha's information or the array, right? Again, I'll be comparing 16 and 16. Again, this is the case where both are equal. So we can take any one of them, okay? Maybe I can take the Sasha's one, right? So I'll just write 16 and then till 17, right? And then my pointer, note that this is not the end of the array. My array is ending at up here, right? So 18:30 and 23:59. So again, I'll just compare 18:30 and 16, right? So which is less? 16 is less, right? So I'll just write 16 again. So 16 till 18, right? And then again up here, this is not the end of the array. My array is ending up here, right? I'll just check that if it's in the recording process. Yeah, it is. So again, I'll just compare here, right? Again, I'll just compare here. So this is 20 and this is 18:30. So definitely 18:30 is less, right? So I'll just write 18:30 till 23:59, right? And then at the end of the day, we are left with only one element up here or one tuple or one information. So I'll just put it in or push it in or append it into the new array, right? So 20 till 23:59. As simple as that. So actually my bracket should not go here. That's illogical. So this should be going up here, right? So this is the entire merged kind of an array, right? And it looks big and it's not really big. It's the length is n1 plus n2, right? So the space complexity, additional space complexity in the algorithm will be big O of n1 plus n2. And again, that's something I'll be discussing in the code part, right? Again, the time complexity here was big O of n1 plus n2, okay? So now that I have the merged parts here, right? The merged parts are here. I have to kind of flatten the information I have in the merged part, okay? I have to kind of flatten the information I have in the merged part. What do I mean by that is, what if, just forget about this question, right? Just forget about this question as of now. What if I tell you few time stamps here, right? So few timestamps. So for example, few timestamps like 9 till 10, right? So this is the timestamp of person 1, and for person 2, 9 till 10:30, maybe like I'll just write 9 till 9:30, okay? Now just imagine this one timestamp, okay, for both of these persons, or both of the people, whatever you may call it. Now you can kind of see here, right, that person 1 is having a time, or person 1 is busy from 9 a.m. till 10 a.m., right? And person 2 is busy from 9 a.m. till 9:30 a.m., which means person 2 is free. So person 2 is free from 9:30 a.m. till 10 a.m., right? Because you can see here that person 2 is having a meeting from 9 a.m. till 9:30 a.m. and he's kind of free between 9:30 and 10. So kind of 30 minutes gap, right? But is P1 free? Is person 1 free till 10 a.m.? Or is person 1 free from 9:30 till 10 a.m.? No, he is not, right? So can I schedule a meeting of 30 minutes here? No, definitely I cannot, right? So I am going to be considering this whole information as this. So 9 till 10 a.m. Okay, my bad. So this should be written as 9 till 10 a.m. right? Why am I writing both of these information into one single information like this? Because I know for a fact that 9 till 9:30 kind of comes in between this, right? So 9:30 kind of comes in between this, and it's kind of an overlapping thing, right? So it's kind of an overlapping thing. So in a diagrammatical view, this should look like this. So if this is something like this, right? So for example, this is like this, right? So this is 9 a.m. till 10 a.m. This is for the person 1, and for the person 2, I'm just going to use the green color. It's 9 a.m. till, for example, 9:30 a.m. right? This is not exactly half, so pardon for that. So I can see here that this area, right, or this timestamp 9 a.m. till 9:30 a.m. right, is kind of falling in between 9 a.m. and 10 a.m. So I know for a fact that I can just simply, instead of writing both of those information, I can just simply write 9 a.m. till 10 a.m. right? So 9 a.m. till 10 a.m. and this modification is kind of known as flattening, right? So this is what we are going to be using here. And again, this is the part where the complexity of algorithm will come into play, okay? Or not about the time and space complexity, but about the toughness, okay? So basically, what I'm going to do is I'm going to merge, or maybe like try to modify the information. So new merged, right? So new merged will be basically, right? I can kind of see here, right? Let's just figure out. So from 0, right? So I'll just write 0 till. What will be the till? I mean, what will be the endpoint here? Let's consider the endpoint is 9. Okay, let's consider the endpoint is 9. Okay, I'll just write 9. But again, I'm seeing here that 0 till 9 is overlapped, or 0 till 9 comes in between 0 and 10. So I can again modify this end value as 0 till 10, right? As simple as that. Again, I'll just check here that I have an information from 9 till 10:30, right? So from 9 till 10:30. Okay, that's one information. So I'll just kind of write here 9 till 10:30. Okay, that's 10:30. Again, I'm seeing that 9 till 10:30, right? 10 is kind of falling in between 9 and 10:30, right? So 9:30 and 10:30, 10 is in the middle, right? Or you can kind of figure out, right? So 10 comes in between 9 and 10:30. So I can kind of write this as, so for example, if I just write 10 till 11:30, right? It's as simple as that. Again, we can kind of map this back, right? How do I do that? I can see that 9 is falling between 0 and 10, right? Okay, that's one observation. So kind of 9 is falling in between 0 and 10, and it's going till 10:30, right? So that's 10:30. Again, I'm seeing that 10 is falling between this, right? So 9 till 10:30, and again 10 till 11:30, whatever the case may be. So I can kind of write this whole information into one single information, which is 0 till 11:30. As simple as that, right? This might sound confusing, but you might have to pause and kind of understand on your own. You have to maybe use pen, paper, and kind of figure out, right? So what I'm doing here is I'm writing 0 till 10. Why? Because 0 till 9 is falling in between 0 till 10. So I just wrote 0 till 10. Okay. Then I wrote 9 till 10:30. I wrote 10 till 11:30. Again, I saw that 9 is falling between 0 and 10. Okay. I did not do any modification. Then I see that 10:30 is falling between 9 and 10:30 is kind of falling between okay, so 9 is falling between 0 and 10, right? That's fine. 10:30 was there, right? So 9 till 10:30 was given. Again, I'm seeing that up here 10 is given, right? So again, I'm seeing that 10 is falling between 9 and 10:30, right? Again, it's kind of overlapping, right? Overlapping time situation here. And it's going till 11:30, right? So I can kind of write the entire stuff from 0 till 11:30. And even this kind of shows that both Alex and Sasha are not available from 0 till 11:30, right? Let's just see. So up here you can see that till 11:30, right? That's what our claim is, right? That's what my claim is. So my claim is that till 11:30, both Alex and Sasha are not available for 30 minutes. Let's see. So Alex is available from 9 till 10:30. Let's go. Sasha is available from 10 till 11:30. Okay, there is no kind of space for 30 minutes. Again, up here, Alex is starting from 12, right? So that's another case. You might say that, okay, Vaibhav, from 10:30 till maybe 11:30 or 11 o'clock, Sasha might be available. But again, Sasha is kind of busy from 10 till 11:30, right? So that makes sense, right? So you know what I'm trying to say. So from 0 till 11:30, that's something I can write. So what was the information which I wrote here, right? So I wrote the entire, this snippet, right? So from 1, 2, 3, 4. All of these 4 formats, I have combined them and written into 0 till 11:30. So I'll just kind of erase this, right? I'll just kind of erase this entire thing and try to write again. So I have reduced the first part. So this is the first part. So I'll just write first part from 00, right? From 0 till from the 0 midnight till 11:30 AM, right? That's what I'm trying to say. Let's consider few other timestamps, right? We are not done with the array as of now. So I'm seeing that it's from, okay, I'll just write it up here in like a rough work, right? Rough work. So 12 till 13. Okay, I'll just write 12 till 13. Okay, that's completely fine. So that this is done. Again, it said 12:30 to 14:30. So 12:30 is kind of coming in between, right? So I can kind of write this like this, right? So 12:30 is coming in between 12 and 13, right? So 12:30 till 14:30. As simple as that. Again, it's saying that 14:30 till 15. So 14:30 is kind of starting up here itself, right? So 14:13 till 15. Okay. So you can kind of see here, right? I've shown this in a very beautiful diagrammatic way. So I'll just pick 12 and this 15. Okay. So this will be 12 till 15. And again, if you kind of go back in the video, or if you have written down already in the notes the timestamps, you can kind of see that Alex and Sasha both are not available between 12 till 15, or it means that between 12 p.m. till 3 p.m. Okay. So this was for the second one, right? So what was the second one ranging from? Second one was ranging from this much, right? So 12 till 15. So this is the second part. As simple as that. And again, I have just shown in the diagrammatic way in the rough work. Okay. Again, I'll be doing for maybe like maybe we can have 1 or 2 or 3 or more, whatever the case may be, timestamps. So we have 16 till 17. Again, I'll just write it in rough work. So 16, so I'll just write it properly. 16 till 17, right? Okay, that's okay. Fine, completely fine. Then we have 16 till 18, okay? So we have 16 till 18. Again, 18 is greater than 17. So I'm just writing it shifted towards the right, right? Shifted towards right from 17, right? I could have just written 18 up here, but that won't really make sense. I want to kind of map it on a timeline kind of a thing, okay? So up here again, I can see that 16 till 17 is falling in between 16 and 18. Okay, that's one observation. Let's proceed further. Then there is this 18:30, which is kind of apart from this entire situation. So I won't consider 18:30. So I'll just consider the timestamp 16 and 18. So I'll just write 16 till 18, right? And this was for, I believe so, this one, right? So this one and maybe like this one. So this was for the third one, right? This was the third one combined. Okay, so this is for the third one. Let's look at further observations. Let's kind of pick this one. I mean, we are picking in the order itself. So 1830 and 2359. So I'll just write 1830 till 2359. That kind of says 11:59 p.m. Okay. Then we have 20 till 23:59. Okay. Then again, I'm seeing here that 20 is falling in between, right? And 23:59 is up here itself. So I'll just write it properly. Yeah. So 20 is falling in between and it's going till 23:59. Again, I can kind of map 1830 till 23:59. Why? See, 1830 till 23:59, that's completely fine. And again, 20 till 23:59. So 20 till 23:59 is in between 1830 and 23:59. So I'll just simply write 1830 till 23:59, right? So I'll just write here 1830 till 23:59. As simple as that. As simple as that. My bad. So basically, what I've done here is I've flattened the information, right? So I've flattened the entire information, whatever the entire information was given. I flattened that information into only 4 elements in the array, right? I've just named that as new merged. You can kind of get creative with the names here. Now, what we are going to do after flattening this list or after flattening the information, just look for the various intervals. What do I mean by that is pick one timestamp and look at its endpoint and the start point of the next timestamp. Okay. So what do I mean by that? It's consider 11:30 and 12. Consider 15 and 6. Consider 18 and 18:30. Right? Don't consider 23:59 because we don't have any timestamp further, right? And again, we don't have to consider 0 because we have no timestamp behind for which we could consider the endpoint. So again, what I'm trying to say here is, listen properly, that consider the end one, right, and the beginning one of the so for example, if I represent this as index I, right? So I want to consider the end for index I and the start for I plus 1, right? That's the information I'm looking for. So if I'm currently at I is equal to, for example, 0, I'll consider its end, so 11:30, and then I plus 1. So this will be I plus 1 will be 0 plus 1, 1, right? So 1th index and the start of it, which is 12. And then subtract, right? So subtract their time differences, right? And if it's greater than 30, therefore we have the answer, right? So what are the possible values we can kind of compute here, right? Let's just figure it out. So we have 11:30 till 12. So I'll just write 11:30 till 12. Okay. We have 15, right? We are considering 15 and 16, right? So 15 till 16. Okay. So this should be 15 till 16. Okay. Then we have 18 till 18:30. So 18 till 18:30. And these are the possible time differences between the two, right? You can kind of figure out what I'm trying to say here. So now I'm going to again loop here, right? You can even do this in one loop, but I'm trying to explain it in a proper manner. So again, you have to loop here and check if the time difference is greater than or equal to 30, then kind of have it in the array, else remove it or kick it out of the array, right? I don't want it in the answer. So what was the time difference up here? So it was given that at least 30 minutes, right? It's written in the meeting duration kind of section. So at least 30 minutes. So 11:30 till 12, it's 30 minutes. Okay, the condition satisfies. 15 till 16, it's 60 minutes, right? Or you can kind of consider this as 1 hour. So that here also the condition satisfies. 18 till 18:30, so again that's 30 minutes. So I'll just have the entire thing in the array, right? And you can kind of see here 11:30 till 12, 15 till 16, 18 till 18:30, and that's what our answer was also speaking, right? So our answer was, or the output was expected from your end was 11:30 till 12, 15 till 16, and 18 till 18:30. The coding part will be a little big, right? Or the flattening part will be a little complex, but hey, it's all good at the end of the day. It's going to be easy, right? If you practice, it's going to be easy. So that was the basic explanation from my end. Now I'll just consider, for example, if the meeting duration from the interviewer's aspect of the perspective was 1 hour. So what will be the answer? Let's see. 11:30 till 12, it's 30 minutes. Is it 1 hour? No, I'll just not consider it. 15 till 16, is it 1 hour? Yeah, it is. So I'll consider this. 18 till 18:30, it's 30 minutes. Will I consider it? No, that's not 1 hour. So in that case, when the meeting duration, right? So when the meeting duration is, so I'll just write meeting duration MD is 1 hour. Then in that case, 1 hours, not 1 hour. In that case, my answer will be only 15 till 16, right? That's the only thing I can kind of say to you as of now. So I hope the explanation was clear, and maybe we can meet in the next video, and I'll be coding in Python as usual. Also, if you don't know about merge sort, you can kind of see my very first video on this channel, which is named as Count Inversions, and it uses the concept of merge sort. Entirely, it's not really what we are going to be doing here. It involves recursion as well, so you will learn merge sort from scratch there as well. But up here, we are just going to be simply looping with two indices, right? Again, I have shown this properly. Okay. So I hope the video was crystal clear, and maybe we can meet in the next video with the coding part. Thank you.